Good morning, class. Welcome once again. We're going to talk about our day 2 under Unit 7, Lesson 1. So, we're going to use the Pythagorean Theorem as a test. So, last semester we learned that most of the time, always the large angles are across from the long sides, and small angles are across from the short sides, okay? We're gonna use those ideas to be able to work on these problems here. So large angles are across from the long sides and the small angles are across from the short side, okay? So if you use that idea in the first box, we're gonna order the angle in each of these triangle from the smallest to the largest. So we're gonna take them by side. As you can see here, the longest side is for the small from smallest to largest. The smallest side is 7, so the angle across from it is P. So you're going to write P. And then the second smallest side is 13. The angle across from it is Q. And the largest side is 14. The angle across from it is R. Here we have angles, so we're going to order from the longest side, from shortest to the longest, so in terms of angles. So here, since we're talking about side, here we're talking about ordering the angles when the sides are given. Here we're going to talk about sides when the angles are given. So the shortest angle is 44 and the side across is this ML. The second smallest angle is 48. The side across is this the KL. It's KL. So we're gonna write KL or LK, whatever you want. And the last one is this biggest, and the biggest angle is 88. The side across is MK or KM. So this is how it goes. So the large angles are across from the long sides and the small angles are across from short sides, okay? So today we're going to learn new stuff as well. We're going to use the Pythagorean rules to do some tests to see if we're going to have right angle, obtuse angle, or acute angle. So when you take the square of the longest side, and if it's equals to the sum of the square of the two legs, then we have a right angle. But when the square of the longest side is smaller than the square of the sum of the legs, we have an acute angle. And when we take the square of the longest side, if it's greater than the sum of the square of the two legs, then we have an obtuse angle. So we're gonna differentiate them today. If C square is greater than A square plus B square, then the triangle is obtuse. Why? It's because larger angle are across from the longer sides, okay? It's because larger angles are always across from the longer sides, okay? In other way around, if that sum is equal, if the longest side is equal to the square of the two legs, the square of this, the square of the sum of the two legs, then the triangle is said to be right. This is what we did yesterday when we were talking about Pythagorean theorem, okay? So lastly, if the square of the longest side is quite smaller than the sum of the square of the two legs, then that triangle is said to be acute. So these are another beautiful rule. These are other beautiful rules to to examine acute, right, and long, acute, right, and obtuse triangles. Okay, and the reason is that because smaller angles are across from the shorter side. Okay, smaller angles are across from the shorter side. So this time around we're gonna solve this problem. We're gonna state if each of these triangles is right, acute, or obtuse. So we're gonna always use the big number as C. Make sure you always use your big number as C. So the longest side should always be C for you, okay? So that you will not get confused. So here, the first problem, what is the longest side? Okay, the longest side here is, the longest side here is 10. So you're gonna take C square. You're not gonna put the equality sign, just wait a bit. And then the two other legs are A square plus B square. So when you take A square, your A square, you have 5 squared plus 6 squared. 5 squares give you 25. 6 squared give you 36. And then the sum gives you what? 61. On the other side, your C is 10. So you square it. 10 squared is 100. And when you put 100 here, what do you see? 100 is greater than 61. Let me change the color. 100 is greater than 61. So you can then say here, since C squared is greater than the sum of the square, as in the case here, then it's obtuse, okay? Then you say obtuse. So you're gonna do the same thing here again. The longest side here is 14. So you take 40, you write C first. I'm sorry. C squared, which is 14 squared, and 14 squared is what? 196. On the other side, you have A squared plus B squared. Your A is this is A, this is B. A here, B here, so it's gonna be 12 squared plus 9 squared. Some people usually take the smaller the smaller leg as A and the bigger leg as B. Okay, so it depends on you. Just use something that that'll be okay for you. But the longest side is always the hypotenuse, or the longest side is always C. Okay, so it has not to be confused. And then 12 squared gives 144. And the other one 81. 9 squared is 81. That is 9 times 9. So the sum of this gives 225. And the other side we saw that C squared is 196. As you can see, 225 is greater than 196. So it means C squared is less than the square of the sum of the square of the two legs. So here we talk about acute. Lastly, we have the same problem here. The longest side is 13, so which is C squared, and C squared is 13 squared, so 13 squared is 169. And on the other side, this is my C guy. C is always the longest side, C. And the other side, I'm gonna take this as my A because it's small. It depends on you, whatever you take, it's okay. So you're gonna take A squared plus B squared, and my A happens to be 5. I square it, my b happens to be 12. I square it. 5 squared is 25. 12 squared is 144. And then the sum gives you 169. And c squared is also 169. As you can see, they are equal. Then you can decide to say these two are equal. And since the square of the longest side, which is the hypotenuse, is also equals to the sum of the square of the two legs, then we can say they are right. So we can say this triangle is the right triangle, okay? And thank you very much. Make sure you do your homework.